All right. This is the video for page 213, 35 to 59 odd. The homework was 36 to 60. All right, now on this homework, it just says solve the system. So you can either solve it graphically, by elimination, or by substitution. It's just going to be however the problem is set up, whichever way you think is easiest. All right, so we have 2x plus 5y equals 8 and 6x plus y equals 10. So I would solve this by elimination, because if you multiply the bottom equation by -5, then your y's are going to eliminate. So I have 2x plus 5y equals 8, and on the bottom I'm going to get -30x minus 5y is equal to -50. Remember, always multiply whatever you're multiplying your equation by the other side of the equal sign as well. So your y's are going to cancel, leaving you 2 minus 30 is -28x is equal to 8 minus 50 is -42. Divide both sides by -28, and you get x is equal to okay, so that's going to reduce to positive 3/2. Positive because it's negative over negative. All right, so now you're going to plug 3/2 back into one of the equations. It doesn't matter which one. I'm going to choose the top one. So I have 2x plus 5y equals 8. So 2 times 3/2 plus 5y equals 8. Your 2's cancel, giving you 3 plus 5y equals 8. Subtract 3 from both sides. You get 5y equals 5. Divide both sides by 5, you get y equals 1. So your ordered pair is 3/2, comma 1. Next we have x plus y equals 1 and x minus 2y equals 4. So I'm also going to use elimination on this. I'm going to multiply the top equation just by a negative, so -1, to make my x's cancel. So I've got -x minus y equals -1, and I'm going to leave my bottom equation alone. -x plus x cancels to 0. -y minus 2y is -3y, and -1 plus 4 is +3. Divide both sides by -3 to solve for y. You get y equals -1. Plug that -1 back into the equation. I'm going to plug back into x plus y equals 1. So I plug in -1 for y, so you get y plus -1 equals 1, which is the same as y minus 1 equals 1. Add 1 to both sides, you get x equals 2. So your ordered pair is 2, -1. All right, in 39, we've got some fractions we need to clear. So I'm going to go ahead and put y over 1. So I have fractions all across the board. So we've got 3 and 1 and 3. So it's pretty clear that our LCD is going to be 3, but let's go ahead and go through the motions. 3 goes into 3 evenly, 1 goes into 3 evenly, and 3 goes into 3 evenly. So 3 is our LCD. So 3 gets multiplied by all 3 pieces. 3 divided by 3 is 1. 3 divided by 1 is just 3. And 3 divided by 3 is 1. So you have 1 times x is just x. 3 times y is just 3y. Don't forget your plus sign. Is equal to 1 times 4 is just 4. Now remember, you're writing a new system here. Now down here you've got 4 and 2 and 4. So your largest denominator is 4. Let's make sure all the denominators go into it evenly. So 4 goes into 4 evenly, 2 goes into 4 evenly, and 4 goes into 4 evenly. So 4 is our LCD, so it gets multiplied by all 3 pieces. 4 divided by 4 is 1, 4 divided by 2 is 2, and 4 divided by 4 is 1. Now we multiply. 1 times -1 times x is -x. 2 times -1 times y is -2y equals 1 times -1 is -1. So now this is nice for elimination because your x's immediately eliminate. So you have 3y minus 2y is just y, and 4 minus 1 is 3. So that's nice too. It gives you y equals 3. So you're going to plug back into one of the equations. You've got x plus 3y equals 4, and you know y is 3. So x plus 3 times 3 is equal to 4. So x plus 9 is equal to 4. Subtract 9 from both sides. You get x equals negative 5. So you have negative 5, 3 as your ordered pair. All right, 41. Solve the system of equations. So we have 2x plus 6y equals 8, and 3x plus 9y equals 12. All right, so neither of these are set up to make it to where we can just eliminate with multiplying one of them. So this is one where you're going to have to multiply both of them by something. So remember, figure out if you want to get rid of the x's or the y's. I'm going to get rid of the x's, so you're going to multiply the top equation by this number, the bottom equation by this number. And remember, you need one of them to be positive and one of them to be negative. So I'll make the bottom one negative in this case. So 6x plus 18y is equal to 24. And then negative 6x minus 18y is equal to negative 24. These cancel, these cancel, these cancel. You end up with 0 equals 0. What happens if that happens? Yep, your answer is all real numbers. Good. All right. You've got 4x plus 2y equals 5, and 2x plus y equals negative 1. Let's use substitution for this one because we haven't used substitution yet. So let's solve for y in our second equation. So we're going to subtract 2x from both sides, giving us y equals negative 2x minus 1. And we're going to substitute this into the top equation. So we have 4x plus 2y is equal to 5. But remember, instead of y, we're going to substitute in negative 2x minus 1. So we have 4x plus 2 times negative 2x minus 1 is equal to 5. Now distribute your 2. 4x minus 4x minus 2 equals 5. 4x minus 4x cancel each other out. So you have negative 2 equals 5. Is that a true statement? No, never. So your answer is no solution. If you end up with a false statement, your answer is no solution. All right, so we have 10y minus 2x equals 1, and 5y equals 4 minus 6x. Let's use elimination on this one as well, but let's add 2x to both sides to get them right on top of each other. So we've got 10y is equal to 1 plus 2x, and 5y is equal to 4 minus 6x. So do you guys see why I did that? Now everything lines up with each other. Okay? So what am I going to have to multiply one of the equations by to make something cancel? I've got 2x and negative 6x. If I multiplied the top equation by a 3, I could make the x's cancel, right? So let's do that. So that would give me 30y is equal to 3 plus 6x. And then down here I've got 5y equals 4 minus 6x. So that makes my x's cancel, giving me 35y is equal to 7. Divide both sides by 35, and that gives you y equals 1/5. You're going to plug that back into one of the equations. I'm going to choose this bottom one. 5y equals 4 minus 6x. So instead of y, I'm going to put 1/5 equals 4 minus 6x. Your 5's cancel, leaving you 1 equals 4 minus 6x. Subtract 4 from both sides. You get negative 3 equals negative 6x. Divide both sides by negative 6. You get 1/2 is equal to x. It's positive because a negative divided by a negative is a positive. So your ordered pair is 1/2, 1/5. So we have 5x minus 2y equals 27, and negative 3x plus 5y equals 18. So there aren't any numbers that I can multiply negative 3 by to make it 5, or negative 2 by to make it 5 here to get rid of the x's or the y's. So I'm going to have to go ahead and multiply both equations by something if I want to use elimination. So because I've got a negative here and a positive here, or a negative here and a positive here, I can get rid of the x's or y's, it doesn't matter. Let's go ahead and get rid of the y's since we've been consistently getting rid of the x's. So, since I have to multiply both equations by something, let's go ahead and set up to do that. Since I have to multiply both equations by something, I'm going to multiply the bottom equation by this number and the top equation by this number, just like I did before. So the bottom equation is going to be multiplied by 2, and the top equation is going to be multiplied by 5. 2 because of this number, and 5 because of this number. So I have 25x minus 10y is equal to whatever 27 times 5 is, 135. And then down here I have negative 6x plus 10y is equal to 36. Alright, so your y's are going to cancel. 25x minus 6x is 19x is equal to 171. Divide both sides by 19. 171 divided by 19 is 9, so x equals 9. And now we're going to plug that back into one of the original equations. It doesn't matter which one. I'm going to choose the top one. So 5 times 9 minus 2y is equal to 27. So 45 minus 2y is equal to 27. I'm going to subtract 45 from both sides. So I have negative 2y is equal to negative 18. Divide both sides by negative 2, and you get y equals 9. So your ordered pair is 9, 9. Alright, so this next problem is set up perfectly for substitution. So I'm definitely going to use substitution. It's already set up with x equals. So I'm going to plug in 3y plus 2 in for this x right here. So I have 5x minus 15y equals 10. But instead of x right here, I'm going to plug in 3y plus 2. So 5 times 3y plus 2 minus 15y is equal to 10. Distribute the 5. So you have 15y plus 10 minus 15y is equal to 10. 15y minus 15y is 0. So you have 10 equals 10, which is a true statement. So your answer is all real numbers. Alright. Here's another one that's set up perfectly for substitution. Y is negative 2x. So where it says y, I'm going to put negative 2x. So I have 2x minus y equals negative 1. But instead of y, I'm going to put negative 2x. Just be careful with your negative. So 2x minus negative 2x. Make sure you use parentheses or you're going to miss out on a negative there. So add a line, change the sign. You have 2x plus 2x equals negative 1. So that's 4x equals negative 1. Divide both sides by 4. You get x equals negative 1/4. Okay, now you're going to plug that back in to the one that says y equals, because we want to know what y equals. So y equals negative 2x, but x is negative 1/4. So I'm going to plug in negative 1/4. So y equals, remember, multiply straight across. Negative 2 times negative 1 is positive 2. 1 times 4 is positive 4. So your answer is 2/4, but we don't leave it as 2/4. Your answer is 1/2. So your ordered pair is negative 1/4, 1/2. Alright, this is another one that's set up perfectly for substitution. We have 2x equals 6, and y equals 5 minus x. All right, so here we're going to substitute 5 minus x. Oh, I lied. We're going to solve this one for x, so we can substitute it in here. So let's divide both sides here by 2, and we're going to get x equals 3, and then we're going to sub that in here. So we have y equals 5 minus x, and we know x is 3. So y equals 5 minus 3, so y equals 2, and we know x is 3, so our ordered pair is 3, 2. Okay, so you're going to have to clear the fractions. So you're going to have to find the LCD. So the LCD between 2 and 3. So you're going to start with 3. You're going to say, does 2 go into 3 evenly? No. So try 6. Does 2 go into 6 evenly? Yes. Does 3 go into 6 evenly? Yes. So it's 6. 6 divided by 2 is 3. 6 divided by 3 is 2. Make sure you put parentheses around your expressions. So you have 3 times x plus 5 equals 2 times 6 minus 4y. So go ahead and distribute. You have 3x plus 15 is equal to 12 minus 8y. Now I'm going to add 8y to both sides, giving me 3x plus 8y plus 15 is equal to 12. And then I'm going to subtract 15 from both sides, giving me 3x plus 8y is equal to negative 3. So that's one of my equations. And then here, I've got 5 and 10. So I'm going to try 10. Does 5 go into 10 evenly? Yes. Does 10 go into 10 evenly? Yes. So my LCD is 10. So I have 10 divided by 5 is 2, and 10 divided by 10 is 1. So when I multiply, I get 2 times 3x is 6x equals 1 times 21 minus 7y is 21 minus 7y. So I'm going to add 7y to both sides. So I have 6x plus 7y is equal to 21. Okay, so those are my two. So this is my new system. 3x plus 8y is equal to negative 3. And 6x plus 7y is equal to 21. Okay, so let's figure out how I can solve this system. So I can solve it by elimination if I multiply the top equation by a negative 2, because that would give me negative 6x here, which would cancel my 6x here. So let's go ahead and do that. Let's multiply my top equation by a negative 2. So that's going to give me, I'm going to start it over here, negative 6x minus 16y is equal to positive 6, and then we're going to leave our bottom equation alone. Okay, so those are going to cancel. Negative 16y plus 7y is just 9y is equal to 15. Divide both sides by 9, and you get y equals okay, back this up. 6 plus 21 is 27. I subtracted. There we go. So 27 divided by 9 is 3. So y equals 3. And you take y equals 3 and you plug it into either one of the equations, doesn't matter which one. So you have, I'm going to do the bottom one, 6x plus 7y is equal to 21. And instead of y, we're going to do 3. So I have 6x plus 21 is equal to 21. Subtract 21 from both sides. So you get 6x is equal to 0. Divide both sides by 0, and you get x is equal to 0. So your ordered pair is 0, 3. All right. And on 57, we have 4x minus 7y is equal to 7, and 12x minus 21y is equal to 24. So I think the easiest thing to do would be multiply the top equation by negative 3, which would give me negative 12x plus 21y is equal to negative 21. And then you have 12x minus 21y is equal to 24. So these cancel, leaving me 0 on the left side. And then you have positive 3 on the right. 0 equals 3 is not a true statement, so your answer is no solution. All right, and then the last problem, you have fractions. So we're going to go ahead and clear the fractions. So you have 3, 4, and 1. So the largest one is 4, and you ask yourself, does 3 go into 4? No, it does not. So our LCD can't be 4. Okay, let's try 8. Does 3 go into 8 evenly? No, it does not. Okay, let's try 12. Does 3 go into 12 evenly? Yep. Does 4 go into 12 evenly? Yep. Does 1 go into 12 evenly? Yep. So it must be 12. 12 divided by 3 is 4. 12 divided by 4 is 3. And 12 divided by 1 is just 12. So you have 4 times 2 times x is 8x. And then negative 3 times y is negative 9y equals negative 1 times 12 is negative 12. And then down here you have 6 and 8 and 1. So we're going to count by 8s. Does 6 go into 8 evenly? No. So we're going to try 16. Does 6 go into 16 evenly? No. So we're going to try 24. Does 6 go into 24 evenly? Yes. Does 8 go into 24 evenly? Yes. Does 1 go into 24 evenly? Yes. So we're going to use 24. 24 divided by 6 is 4. 24 divided by 8 is 3. And 24 divided by 1 is just 24. Now we're going to multiply. 24 times negative 1 times x is negative 4x. 3 times y is 9y. Equals 24 times 1 is just 24. So our 9's actually cancel for us, which is nice. Giving me 8x minus 4x is just 4x equals negative 12 plus 24 is positive 12. Divide both sides by 4. You get x equals 3. Plug back into one of the equations, doesn't matter which one. So I have 8x minus 9y equals negative 12. We know x is 3, so 8 times 3 minus 9y equals negative 12. 24 minus 9y equals negative 12. Subtract 24 from both sides. Negative 9y is equal to negative 36. Divide both sides by negative 9. You get y equals positive 4 because a negative divided by a negative is a positive. So your ordered pair is 3, 4. And that is it. So you guys have a good night, and I will see you tomorrow.